Good morning, grade 7. We are now in the activity part of Module 1, Mix 1 to 4 for the fourth quarter. As you can actually observe, okay, our last activity is activity number 4, which is the report sheet, your performance task. Let me check on the attempts that we have. Okay, you have Jairus, Jaden, RJ, Levi, and Kaizel. So for the benefit of those who did not yet submitted the report sheet, I'll be updating this for the last time. RJ, can I assign this to you again? Please inform. Yes, please inform your classmates that I'll be opening activity number 4, your report sheet, for the last time. Why? Remember that this is 40% of your grade, number 1. Okay? And this can actually pull your grades down if in case. Right? So today is May 4. Yeah, it will be closed by afternoon at 5 p.m. So no other excuses. You might give me an excuse that, sure, I don't have internet connection at all. They're already giving you a lot of chances. Okay, reminding everybody also to check on your activities one by one. Why? Because we are in the middle of recording your raw scores. Okay? We are in the middle of recording your raw scores. We don't have the luxury of time waiting for your answers, right? I already messaged you in our GC that this is a collaborative effort. You need to do your part and I will do my part, right? How about your learning resource material for Science 7? I already received, by the way, last Friday, I think, I received a learning resource material from grade 7. It's from Kaiser, okay? He actually used the concept of soil profile. And it's good. That's the actual science concept, right? That's one good example. What are the other examples for your science concept? Okay, let me share this again. Okay, let me share this. Hold on. Okay. For physical outputs, let me have this one. Right, students output. For physical output, we can have this one. Yes, Kaizel. Layers in the atmosphere. Yes, it is actually part of your lesson. Okay. Okay, let me share this in the class. Okay, this is one good example of a physical output. Okay, this is made out of, again, illustration board, which is on the base. Okay, with the labels, as you can see. Okay, these are the labels, the different parts, with the legends also. And this is made out of styrofoam and, of course, tissue paper. And with the coloring material, which is your poster paint. As simple as that. So that is the science concept. This is under circulatory system. Okay. And also, again, as you can see, red color lines here or arrows indicate that the blood is with oxygen and blue with carbon dioxide. So as simple as that. Okay. This is under physical output. How about digital output? If you want digital output, you can actually do this one. Similar to this. Okay, let me share this in the class. This is actually the output from last school year. Okay, grade 10 last school year. This is their year-end output. Okay, hold on. Right. Again, your digital output may categorize into two. We have the vlogging and the video documentary. Let's have vlogging first. Okay. This is one good example of a vlogging. After which, please give or please share to the class what you had observed out of the concepts that had been discussed by the grade 10 student. Hold on. Okay. Let me share this to the class. Can you see the shared screen now?
Yes.
Yes.
Well,
Hello everybody, it's me, Kaylee Maxine Velosa, and for today we're going to be talking about a very interesting topic, gas laws. Let's start fresh. What are gas laws?
Well, gas laws are examples of scientific laws. These are statements that describe, summarize, and predict a range of natural phenomena by means of repeated experiments and observations. Gas laws are laws that relate variables pressure, temperature, volume, and amount mathematically in order to make predictions about gas behavior, which is given in the kinetic molecular theory. Now, let me briefly introduce to you the gas laws and some of their real-life applications.
Formulated by Robert Boyle in the year 1662. This law describes the relationship between volume and pressure, claiming that the two variables are inversely proportional, which means that when the exerted pressure of a gas increases, the volume it occupies decreases, given that the temperature and amount is held constant. So when one goes up, the other goes down.
Deep-sea creatures are unlikely to survive on the surface of the waters because they are used to high pressure. Once they are brought up, decrease of pressure allows the gases in their bodies to expand, causing their air bladder and cells to rupture.
Charles's law, proposed by Jacques Charles in 1802. Given that the pressure is held constant, a gas's absolute temperature and the volume it occupies is in direct proportion, which means that what happens with one variable also happens to the other. An increase in temperature causes a corresponding increase of volume.
This law can be applied to baking. If you want your bread and cake spongy and soft, you would need yeast. Yeast is a leavening agent that converts sugars in the dough to carbon dioxide. Once the dough is put into the oven and baked in high temperature, the dough's gas expands, resulting to a spongy soft appearance for your pastry.
The relationship of the temperature and the pressure of a gas is described in a Montan's law, discovered by Guillaume Montans in the late 1600s. Just like the previous law, this law also describes a direct proportion relationship. When the temperature of a gas increases while the volume is held constant, it causes the pressure to increase too. He discovered this while building an air thermometer.
According to Montan's law, higher temperature results in higher pressure. The air pressure in tires increases as the temperature rises.
Driving excessively raises the temperature of the air in the tires. Doing that, especially in this hot weather, may blow up your tires due to overinflation. Better get your tires checked to avoid risky scenarios.
A pressure cooker is a cooking device that cooks food quickly. While the food is being heated inside, its fixed volume container traps the steam being generated, and as steam builds up, the pressure increases. This law is simply a combination of the three primary laws we just tackled. There are specific events that involves the variables temperature, volume, and pressure. Hence, requiring a combination of the three laws caused the discovery of the combined gas law.
Our lungs are the containers that hold air. As swimmers dive in the depths, they make sure that they know how to adjust to maintain proper pressure balance between their lungs and the water. Because the water pressure increases, and like stated in Boyle's law, volume will decrease. And applying Charles' law, diving in cold waters may squeeze your lungs until there's no air left for you to breathe. Same goes with diving on a warm weather. The volume of air in your lungs may expand quickly. Without exhaling, the air will build up inside.
Proposed by Amadeo Avogadro in the year 1811. This law states that under the same temperature and pressure, equal volumes contain an equal amount of molecules.
When blowing up balloons, the volume increases as you release gas particles into the balloon from your lungs. The balloon's volume will expand as you force more gas particles to it.
Just like the combined gas law, but the Avogadro's law is added. Scientists wanted to study the relation of gas molecules to its environment, but upon brainstorming for the perfect equation, there are always affecting factors such as intermolecular forces. So, they just came up with this gas equation to study gas behavior, despite some minor factors.
Airbags installed in cars is controlled by a sensor that detects a crash. When the car crashes, the controller alerts the system, triggering an inflator that burns chemicals such as sodium azide very rapidly to produce large volumes of gas to inflate the airbag. While this happens, the bag is also being compressed when deployed, decreasing its volume, resulting to its pressure to rise. However, the gases are being neutralized to prevent the bags to overinflate. And seconds later, after the deployment, the bags will start to deflate in order for you to get out of the car.
Lastly, we have the Dalton's law of partial pressures, discovered by John Dalton in 1801. This law states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the individual gases.
This law is especially applied to atmospheric studies. The atmosphere is made up of gases, mainly nitrogen, oxygen, and carbon dioxide, and water vapor. Put together all the partial pressures of these individual gases, we get the total atmospheric pressure. Now you know the basic concepts and applications of these gas laws. I hope you learned a thing or two from this video, and I hope you understand the importance of these laws. Studying gas laws are important simply because these gas laws apply to our everyday lives. You may not realize the things you feel, see, hear, and smell can be explained by gas laws. These can even save your life. Till next time.
All right. What had you observed out of the video? This is actually under vlogging. Okay. This is a video blog of their concept or topic, gas laws. That is actually the project of grade 10 last school year. Anyway, so what had you observed? Any observation? There is the audience. Yes.
There's
That's our target.
clips.
RJ, come again.
She uses clips and like she adds like text and pictures.
Yeah, correct. That's a good observation. Of course, the main target or goal of our learning resource material is to educate, number one. This also should explain the science concept that we have in fourth quarter, weeks 1 to 4. Okay. What else? Any other observation?
She explained it properly and understandably.
Yes, correct. That's a good observation also, Jaden. She explains it properly and understand it. Yeah. Any other observation aside from that? Any other observation? All right. As you can observe in the video, it explains the concept. That's the primary goal. Okay, number one. Number two, it should be 5 minutes up, but not more than 20 minutes. Okay, your video would look like boring if in case. What else? It should also give practical applications. What are the practical applications of these concepts? Why? Because these science concepts are not just inside the book. These are not just for theoretical or for in order for you to pass for grades only. No, this should be applied. Okay, science concept should be applied. That's why we have practical applications. Number three, as you can observe in the video also, okay, they included the sources, okay, as credits. Why? Because they didn't actually own those videos. These videos should be credited on the sources. Where did you get those videos? And of course, these videos are narrated. That's under vlogging. How about under documentary? How can we have the documentary? Sure, if we will choose the video documentary. Okay, let's have this example. This is a good video documentary actually. Okay, from grade 10. Hold on. Let me share again this to the class. Can you see the video now?
Yes.
Okay.
Yes.
Over the centuries, experts have been studying something that is unseen in our naked eyes, and that is gas. And since it is different from more visible things, studying this element is more difficult. For that reason, scientists came up with some things that are helpful for them to study gas itself, and those are the gas laws. Additionally, there were plenty of experts who have formulated their own gas laws, and each gas law has their own uses. However, how can we apply this in our daily lives? Let's find out in this video. This is Christian Inario, and you're watching Science Matters. Studying science is interesting, and this makes us formulate a lot of questions. For this topic, we tend to ask, what are the applications of these laws in our daily lives? To begin with, we will talk about the Boyle's law. This describes how the pressure of the gas tends to increase as the volume of the container decreases. According to the rule, if the volume is large, the pressure is low, because the particles cannot move quickly because they must move in a large container. On the other hand, if the volume is small, the pressure is high because the particles must move in a smaller container. You can observe a real-life application of Boyle's law when you fill your vehicle tire. As you push air into the tire, the increasing pressure reduces the volume of the air molecules by packing them together. The pressure in the pump has to always be higher than that which is inside the tire in order for more air to be pushed in. As the air temperature is more or less constant in that period of time, you can see a real-life example of Boyle's law occurring in front of you. We are down to our next law, and that is Charles' law. This law describes how gases tend to expand when heated. According to the law of Charles, volume and temperature are directly proportional to each other. A real-life application of Charles' law would be your vehicle tire. If you read your owner's manual carefully, it will mention that tire pressure should always be measured cold. That's because driving around heats up tires. Charles' law states that the gas should always occupy more space when heated. But the tire does not expand very much. This causes the tire pressure to be higher when warm. Consequently, measuring tire pressure when the tire is warm will give you the false impression that you have filled your tires with too much air. Now, we are going to discuss our third gas law, and that is the Avogadro's law. According to this law, the same amount of gases at the same temperature and pressure emit the same number of molecules, regardless of their chemical and physical properties. In other words, as temperature and pressure remain constant, gas is directly proportional to the number of gas moles. A real-life evidence of this law is whenever you blow up a balloon. The volume of the balloon increases as you add moles of gas to the balloon by blowing it up. Basically speaking, the more moles, the larger the volume will become. Now, this law states that the pressure of an ideal gas varies directly with the absolute temperature when the volume of the sample is held constant. This means that lower temperature means lower pressure, and higher temperature means higher pressure. A real-life example of this is your vehicle tire. In hot summer days, the inflated tires of vehicles
Again, let me share it to the class. Okay, hold on. Okay.
A real-life example of this is your vehicle tire. In hot summer days, the inflated tires of vehicles may burst. The bursting of tires is caused by a Monton's law. The inflated tires are under high pressure. When the temperature of the air rises, the pressure of the gas in the tubes also increases. After an unbearable point, the tires fracture. However, what makes gas law important? Actually, gas law make the studying of gases much easier. They can be used to determine the parameters of a mass of gas using theoretical means. For that reason, these said gas laws are truly of great importance, and I do believe that they are useful when studying the things that are not seen. Remember, there are still gas laws out there not being mentioned here. For that reason, I encourage you to do your research and be limitless. This has been Christian Inario, and always remember that science matters.
All right. What had you observed out of the video? This is under documentaries, narrated. What had you observed?
Every gas law.
Every gas law is explained. It's a good also observation.
Every
What else?
gas law.
What else?
He explained why gas laws are important.
Yeah, the importance of the concept. Okay. It explains, thank you, RJ. It explains the importance of the science concept. Why do we need to know this and that? Why do we need to know the science concept much? Okay. You need also to include the importance of that particular science concept that you had chosen. Right? Again, let me remind everybody, okay, I am actually rolling out the activities that I have here. Okay, let me remind everybody to please check on your activities one by one. Okay, and if there are some missed activities, please let me know so that I can assist you with your concern. I can actually open it in case. For fourth quarter, we have activities 1, 2, 3. Three activities, one performance tasks, which is the report sheet, and of course, your learning resource material, which is 100 points. This is equivalent to 100 points. All right. Do you have any questions so far with the learning resource material?
No, sir.
No.
Okay, let me remind you also the deadline for the learning resource material. This is actually this May 13th, 2022. That's next week. Okay, the deadline for your learning resource material is next week, May 13, 2022. Okay, at 5 p.m. respectfully. Okay, your major exam is fast approaching. That is May 16, 17, and 18. Okay, that's the 3 days. And of course, the coverage for your major exam is your fourth quarter, weeks 1 to 4. Okay, module 1, which is the Philippine environment and its resources. Okay, we covered all of them. I am now at the middle of recording your raw scores, and I'm just waiting for the report sheet. And of course, major exam, your fourth critical test, and your project. And that's it. You can generate now your grades. Right? Do you have any concerns, questions so far?
No.
No.
All right. I think that will go for today, class. Thank you for your participation. Grade 7, let me record first your attendance. Okay, we have Jayden, Jairus, RJ, Mariana, Levi, Travis, and Kaizel. Okay, thank you for participation, everybody. Have a nice day, grade 7. Take care. Bye-bye. Enjoy the rest of the day.
Bye.